All right, welcome back again. Algebra 1. Okay, here we go. We're in section 5 today, talking about solving polynomial equations in factored form. Okay, so we are kind of slowly, we're moving away from that division that we've been doing for the past, seems like at least 2 days, okay? And we are moving into starting to understand what factoring is like. Okay, so when you think of factoring, that means you are looking for the parts of a polynomial that are actually the same, like what they're sharing. Okay, so let's get into the notes. Everything again that's highlighted, all these little example problems, stuff right here, copy that down. Okay, so when you're solving a polynomial, the key thing you're doing is you are setting it equal to 0. Okay, and let's say you have different binomials, or if you have a monomial, okay, then you're going to set the monomial equal to 0. And here's what I mean. Here's an example of that. This is a monomial set equal to 0. And if you solve it, this is what you'd get. X is 0. Here is a binomial. And how do we solve that? We actually solve it by setting each of them separately equal to 0. X plus 5, that's right here. Set it equal to 0, you get -5. X minus 5, set it equal to 0. What do you get? You get a +5. That means you have 2 answers because we had 2 parts. Okay, so if they give you a monomial, set it equal to 0, solve it. 1 answer, 1 part. If they give you binomials, 2 parts, notice again, binomials 2 parts, set each of them equal to 0, and you will be given 2 answers. Okay, so make sure you're paying close attention. Set them equal to 0 if they ask you to solve. Now, the next thing, if they ask you to find the roots, that's the same thing as asking you to solve. So for whatever reason, if you think of it as the roots are more like if you were to graph it, it's where it would cross the x-axis. So if I'm, drawing a graph and it creates, let's see, this type of shape right here, notice how it would cross in 2 spots. That would be kind of like this guy right here. Like if I were to graph that, it would cross in 2 spots. I'd have 2 answers. There'd be 2 solutions. That's another way of saying I'd have 2 roots. All right, all of those words aside, if they say find the roots, it's the same thing as them saying solve it, find what x equals. Okay, that's the key piece to remember. All right. And in all honesty, that's the only bit of notes I'm going to give you, because this last piece here, let's just do a lot of example problems together. Let's see how these problems work out so you can see it. If you have questions, write them down, bring them to class. I'll do those problems on the board. So let's go through some example problems. Here, what they do is they give us binomials. All right, we're going to have to set them individually equal to 0 and solve them. That's all we're doing. X plus 2 equals 0. X minus 3 equals 0. Solve them separately, individually. Okay, simple enough. -2 minus 2, x equals -2. Well, there's one of my answers. +3 plus 3, x equals 3. We like those. That's it. That's how you solve these types of problems, like that. Okay, give you 2 parts, you're going to get 2 answers. All right, let's move on. Example problem number 2. Now comes this idea of learning how to factor things out. Okay, when you factor things out, what you're looking for is what each term shares. And what I mean by shares, I mean common factors. Okay, so let's take a little time out. You have 14 and you have 35. Let's think about common factors that they each share. All right, if I break this down, I could say it's 7 and 2. If I break this down, I could say 7 and 5. Notice I have the common factor of 7, and it just so happens to be the greatest common factor. Remember back to when we were doing problems with GCF, greatest common factor. 7 is the greatest common factor. So I'm going to take a 7 out of 14 and 35. This is how you write that. Pull a 7 out. Write it on the outside of a set of parentheses. They each have a 7. I pull it out, writing it on the outside of the parentheses. Now I have to rewrite after I've taken that 7 out. I have 2 left over here. I have 5 left over here. The x and the y, there's nothing common. X is x, y is y. They don't have anything in common. This is your solution. You factor out what they share, then rewrite in parentheses what's left over. But you can never forget what you factored out. That has to be written outside the parentheses. It doesn't just disappear. It's still there. All right, let's do another problem. Same concept, factoring out common terms here. Okay, there's a 4, there's a 24. Let's think, what is the GCF? What's the greatest common factor between 4 and 24? It's in fact the number 4. 4 goes into itself once. 4 goes into 24 6 times. So 4 is the biggest number that can go into 4 and 24. All right, so we take a 4 out. Now you have to look at the variable. There's an x, there's an x. Okay, well, they're common. X and x, those are both common. On this side, I have 4 x's. On this side, I have 3 x's. So what do they both have in common? They both have 3 x's in common. Here's how you know that. If you have 4 x's, and then the other side has 3 x's, I would then ask you, how many x's do they have in common? They have 3 x's in common. This one is left out because I can't say they had that last one left in common. So that means I'm also taking out x to the power of 3, pulling that out. So now what do I have left over? I had a 4, but I took 4 out, so that's gone. I have 4 x's. I took 3 of them out. That means I have an x left over. 24 divided by 4 is 6. Now look, I had 3 x's. I took all 3 x's out, so I don't have any. We can close this up a little bit more here. I don't have any x's left over in that second term. So this is all about greatest common factors for both numbers and the variables. Okay, let's do another one. Let's keep walking through these problems. This is 2 concepts put together. We're going to factor things out, and then we're going to solve with what we factored out. Let's take a look at what we got. We got a 3 and a 9. What is the biggest number that 3 and 9 both share? 3. In fact, it's 3, right? 3 can go into itself, and 3 can go into 9. So we're going to take out a 3. Now look at the variables. I have 2 x's on this side. I have just 1 x on this side. So how many x's do they at least share? They share 1 x. So I take 1 x out. Okay, if we really expand it, just for those of you that want to get the full visual here, the number 3 breaks down just to 3 and 1. The number 9 breaks down into 3 and 3. All right, so let's look. They both share a 3. That's why I took a 3 out. Okay, now let's break down the x's. There's an x, there's an x. The other side just had that x. What do they both share? They both just share one x, leaving an x left over. Don't forget about that 3 that was left over there. So now what do we have left over? That's what we're writing in the parentheses. You had an x left over on that side minus a 3 left over on the other side. We can bring that in. So this is what you're left with. You're left with a monomial 3x and a binomial x minus 3. But the problem says solve it. So now we're going to take each of these and set them equal to 0. 3x equals 0. X minus 3 equals 0. Solve each of these problems. Divide both sides by 3. X equals 0. Add 3, add 3. X equals 3. So the final answer they're looking for is x equals 0 and x equals 3 for this problem, example problem number 4. All right, let's do example problem number 5. Here we go. Find the roots. Remember, find the roots, fancy way of just saying solve it. We're going to do the exact same thing in this example problem number 5. First step, what do they share? I see a 4, I see a 2. What is the greatest common factor between 4 and 2? The greatest common factor is the number 2. 2 goes into itself, 2 goes into 4. All right, so we're going to write the number 2 on the outside. Now look at the variables. This side has an x. This side has 2 x's. How many x's do both sides actually share? Only one x. There's an x, but there's 2 x's. They both can only share the common 1x. So take an x out. In parentheses, what do we have left over? Think about this. What's 4 divided by 2? It's 2. What is x squared divided by x? X squared divided by x. There's an x left over. Okay, now what is 2 divided by 2? Well, that crosses out. There's a 1. Then x divided by x, that crosses out. There's a 1. So all you have left right there is a 1. That's important to notice. 2x was right here, but we took out a 2x right here. There's a 1 left over. Many times students will say, well, I took it all out. There's nothing left over. There's a 0. That's not the case. Remember, there's always a 1 left over. Even if you crossed everything out, there's a 1 left over. 2x, but I took out a 2x. There's a 1 left over. Okay, find the roots means now I have to solve 2 individual problems. 2x equals 0. 2x minus 1 equals 0. All right, divide by 2. X equals 0 for this one. Add 1, add 1. 2x equals 1. X equals 1/2 for that side right there. Okay, so those are the actual roots. X is 0, x is 1/2. Okay, final example problem number 6. All right, we got a couple steps here. First step, I'd like to get everything together. So I'm going to take this negative 8x and bring it over, because I want this to actually say 28x squared plus 8x equals 0. That's the key thing. The equals 0 needs to be all there by itself on the other side. Now we can take a look at what we have in common. Let's find that greatest common factor between 28 and 8. Okay, and again, if we want to, we can break this down so you can see it. 28, 8. Let's break it down. 4 and 2. Break it down. That's going to be 4 and 7. So right there, I don't need to go any further. The biggest number they both share is 4. Okay, but what we're going to have left over on this side is a 7, and we're going to have a 2 left over on that side. Then take a look at the x's. All right, this side had an x and an x. This side had just an x. So what we're sharing is we're just sharing an x. So we can take an x out. We can take a 4 out. So let's do that. 4x, take that out. What's left over? 7x plus 2. All right, we took a 4 out. 28 divided by 4 is 7. 8 divided by 4 is 2. Then we took an x out. I have 2 x's, so cross it out. I have 1 left over. There's 1x, but I took an x out, so that guy's gone. That's why all I have is a 2 right there. Now solve each part. All right, 4x equals 0. X equals 0. 7x plus 2 equals 0. Solve it. Minus 2 minus 2. 7x equals negative 2. X equals a negative 2 over 7. So there's the answers for that one. X is 0. X is a negative 2 over 7. Whew, okay, that's good. Let's zoom out so you can see it all. All the example problems there, 1 through 6 worked out. Copy this down, guys. Take the time and the effort to do all of these notes, because that's what it's going to take to understand it and do well when it comes time for your test. All right, bring your questions to class. I'll see you in the next one.